Okay, today's lesson is Chapter 4, Lesson 1. This is going to be on two-step linear equations. So your objective is that students will solve two-step linear equations in one variable with 80% accuracy. One variable just means that in the equation, there's going to be just one variable. So whereas in the future when you're doing this, you might have an x and a y, in this case, you're just going to have an x, okay? So here, I want you to be careful and write exactly what I tell you to write, because if you get ahead of me, you might be writing the wrong thing. So in this one, you're going to write example 1, inverse operations, and solve 3x plus 8 equals 23. Just write that for now. Now, off to the side somewhere, okay, you can write the word solution if you want, but off to the side somewhere is where you're going to write this other box. I've put this other box here, and all I want this box to be about is you knowing which questions to ask yourself before you start solving this problem. So I'm not letting you see the solution yet. So this box that I have, I'll highlight it for you, this whole box here is not the solution, okay? This box is your thinking process. So this is what you should be thinking at this point. I do want you to write it, but I don't want you to write it where it is, under the solution. I don't want it there. You can write it off to the side here or something. So over here off to the side, you can write what operations are in the equation. And then answer the question under it. Okay? So what operations are in the equation? That's what I'm asking you. So let's look at this. 3x plus 8 equals 23. What operations do I have there? So let me read it a different way. Instead of 3x, I'm going to tell you exactly what it means. 3 times x plus 8 equals 23. So what two operations do we have here? 3 times x means, hopefully you said multiply, and you have an addition symbol, so hopefully you said addition. So multiplication and addition are the two. So we have multiplication and we have addition. So we're adding 8 and multiplying by 3, okay? Notice I haven't even talked about the 23 yet. The reason I'm not talking about the 23 is because we're just focusing on the side of the equation that has the x. Always just focusing on that side alone. That's where our operations are. We need to isolate the variable, get it by itself. So first I need to understand what is being done to the variable. Well, it's being multiplied by 3, and on that side of the equation, I'm also adding 8. How do I know it's that side of the equation? Well, the equal sign is your balancing symbol. So here's your equal sign here. There's a left side of it, and there's a right side of it. On the right side is the number 23. On the left side is our 3x plus 8. Because the variable's on the left, that's the side I'm focusing on. Okay? So, now, my next question for myself that I'm going to write is, what is the inverse of addition and what is the inverse of multiplication? So, inverse of addition is, and what is it? Hopefully you said subtraction. And inverse of multiplication is, hopefully you said division. So subtraction and division are the inverse operations. Now, why do I need to know that? because that's what I'm going to be using to solve this problem, subtraction and division. So first I have to identify the operations that are being used, then I have to identify the inverse operations, the inverse of those. Okay? So let's get all this out of the way now and let's look at the actual solving of our problem. So we're going to push all this back, we're going to move our box over. All right. And here's the actual solving of the problem now. So 3x plus 8 equals 23 is the original equation. The opposite of addition was subtraction, so we're going to subtract. How much are we going to subtract? Well, how much is being added? 8 is being added, so we're going to subtract 8. So if we subtract 8 from this side, we have to subtract 8 from this side. Subtract 8 from each side. When I subtract 8 from this side, I combine like terms. 3x plus 8 minus 8, the 8 and the 8 become 0. So I have 3x by itself now. When I subtract 23 minus 8 from this side, combining like terms, 23 minus 8 is 15. So I have the new equation of 3x equals 15, simplified. Okay. I divide both sides by, hold on a second. There we go. Sorry about that. I don't know how that got like that. Okay. I divide both sides by 3 because x are being multiplied by 3. The inverse of multiplication is division. So I divide both sides by 3. Here, divide by 3. Okay. Divide each side by 3. When I divide each side by 3, the 3 divided by 3 is 1. 1 times x is just x by itself. Add 15 divided by 3 is 5. So x equals 5. And the next one. Example 2. Solve x over 4 minus 12 equals 1. So we have a new example here. My solution. First I write the original equation. Excuse me. What operations are being done to x? I'm going to focus on, again, this side of the equation with the x. What's being done to x? X is being divided by 4, and we're also subtracting 12. So what's the inverse of division? Multiplication. What's the inverse of subtraction? Addition. So we're going to use addition and multiplication, the opposites, to solve this problem. Let's do the addition first. By the way, if you'll notice, we're working backwards order of operation because we are undoing this problem. This problem's already been done. X over 4 minus 12 is equal to 1. We already know what it's equal to. It's equal to 1. This problem's already been done. So we don't use the order of operations to solve the problem when there's already an answer. Since we're solving for a part of the problem that hasn't been done yet, x, we need to do the opposite of the order of operations. So whereas before, parentheses, exponents, then multiplication and division, then addition, subtraction, now you're working at the opposite direction. So we're going to do any addition and subtraction first, then the division and multiplication, then the exponents, and then parentheses, if there are any. Okay? So let's take care of this first, then this subtraction. So we're going to add 12 to each side. Add 12 here, then you must add 12 here. Add 12 to each side. When I add 12 here, I combine like terms. X over 4 minus 12 plus 12. Minus 12 plus 12 cancels out to 0. So I just have x over 4. And 1 plus 12 is 13. So now I have x over 4 equals 13, simplified. How do I get rid of the 4 now that's being divided by x, being divided into x? I multiply by 4. So when I multiply on this side, my 2 4's cancel out. Okay. I have x by itself now. And 4 times 13 is 52. X equals 52. All right, I'm just going to go ahead and skip now to the guided practice. Guided practice. Describe the first step you would take to solve the equation. So let's look at what's being done here. Again, we're focusing on the side with the x. We're multiplying 3 times x, and we're subtracting 4. So we have 2 operations, multiplication and subtraction. What do we take care of first? The subtraction. What's the inverse of subtraction? Addition. So we're going to add 4 to both sides first. Okay? That'll go away. Okay, add 4 to each side. So we add 4 here, then we add 4 here. 2 plus 4 is 6. Negative 4, remember we changed this to a negative. Negative 4 plus 4 is 0. 3x. Move this out of the way. 3x plus 0 is just 3x. And now I have multiplication, 3 times x. I divide both sides by 3. Now I have x by itself. And 6 divided by 3 is 2. X is 2. Let's see if that makes sense. That means 3 times 2 is 6. 6 minus 4 is 2. And yes, that works. 5x plus 3 equals 15. So again, focusing on where the x is, I have multiplication and I have addition. The opposite of multiplication is division, and the opposite of addition is subtraction. Take care of this addition first. I subtract 3 from both sides. And I hope you pause this to try doing this by yourself before you're watching it. Okay? Plus 3 minus 3 is equal to 0. So I have just 5x on this side. And 15 minus 3 is equal to 12. So I have 12 on the other side. So 5x equals 12. Divide both sides by 5, sorry. So I have x by itself now. And 12 divided by 5. You could leave that 12 over 5. Or you can change it to a mixed number. 5 goes into 12 2 times. I have a remainder of 2. And the denominator remains the same, 5. Either one of those are fine. They wrote it as a decimal. So another way we could do it as a decimal. Divide 5 into 12. So just remember, when you're changing a fraction, let me erase this. When you're changing a fraction to a decimal, this is when we do our in and out, when we're changing fractions to decimals. So the 12 is in, the 5 is out. 5 goes into 12 2 times, that's 10. Subtract. Now we're going to have to add a decimal and a 0, so you have to add a decimal to your quotient. Bring down the 0. 5 goes into 24 times. 5 times 4 is 20. Now our answer is 2 4/10. Almost 2 1/2. Okay? Number 3, negative 2 equals 2 plus 4x. They switched it around on us, so let's make sure we focus on the right side with the x. We have 4 times x, and we have addition of 2. The inverse of addition is subtraction. The inverse of multiplication is division. So I'm going to use subtraction and division. First, subtraction. If I subtract 2 on this side, I also have to subtract 2 on this side. Remember, here's our equal sign. We have a left side and a right side. You have to do the same thing to both sides. Negative 2 minus 2 more. So you already have negative 2, and now you're subtracting even more. And I say you're subtracting more because it's a positive number. 2 is positive. So minus 2. This 2 is positive. This one. Okay. So negative 2 minus 2 more is going to be negative 4 now. 2 minus 2 here is 0, and I have the 4x. Now we use our division. Divide each side by 4. 4 divided by 4 is 1, so x is by itself. Negative 4 divided by positive 4 is negative 1. So x is negative 1. If I check my answer here, 4 times negative 1 is going to be negative 4. And if I add 2 to that, add 2, I'm going to get an answer of negative 2. And that's my answer, negative 2, so I know it works. So we subtracted 2 from each side, and we get a negative 1. Number 4. I'm multiplying 7 times x. The inverse of multiplication is division. And I'm adding 15. The inverse of addition is subtraction. So let's subtract first. Get rid of that 15. We subtract 15 from this side. Then we must subtract 15 from this side. 6 minus 5 is 1. 3 minus 1 is 2. 15 minus 15 is 0. So we have 7x. Now we have 7x equals 21. We divide both sides by 7 to get rid of that 7. Isolate our variable. X is by itself. 21 divided by 7 is 3. Put it back up in the problem, make sure it works. So I make this 3. 7 times 3 is 21. 21 plus 15 is 36. It checks. Check, check. Number 5. M divided by 5 minus 3 equals 7. I have division. Inverse of division is multiplication. And I have subtraction. Inverse of subtraction is addition. So first the subtraction. I'm going to add 3 to each side. I combine like terms. M over 5 minus 3 plus 3 becomes M over 5. Because minus 3 plus 3 is 0. And 7 plus 3 is 10. Now, I use multiplication to undo this division problem. So I multiply it by 5 over 1, or 5. So multiply here by 5. 5 over 1 times m over 5 is 5m over 5, which is the same as m by itself. 10 times 5 is 50. The answer is 50. So 50 divided by 5 is 10. And 10 minus 3 is 7. So yes, that checks. Last one. 5x minus 7, and this time we're going to justify each step. So, we write the original equation. Write original equation. Next, we're going to add 7 to each side. So we have 5x minus 7, then we're going to add 7 equals 13, and we're going to add 7 here. So our direction is to add 7 to each side. Okay? So when I add 7, I'm going to simplify this now by combining like terms. So let's simplify combining like terms. 5x minus 7 plus 7 is 5x. 13 plus 7 is 20. Now, I'm going to divide each side by 5. So I'm going to divide by 5 here, divide by 5 here. 5x divided by 5 is x. 20 divided by 5 is 4. So this is where we solved it, right? Solve it. Or combine like terms, or not combine like terms, I'm sorry, that's only for addition and subtraction. This is division. So we simplify by dividing. X is 4. And let's check our root to make sure. So I'm saying that 5 times 4 minus 7 is equal to 13. Well, 5 times 4 is 20. 20 minus 7 is equal to 13. Why, yes it is. That checks. Okay? You're done for today. Have a nice night, and I'll be back tomorrow.